Welcome back, everybody, to ECTU. This is our fourth of 5 lectures in a series on environmental law and policy. It's a basic overview of environmental regulations in the United States. My name's Andy Cooper, and I'm glad to be back with everyone again. I'm with Environmental Consulting and Technology Incorporated. We are an environmental consulting firm with 22 offices across the United States, and I'm based here in Chicago, where I'm sad to say it's a little wet, cold, and dreary today. So maybe some of you are having nicer weather. I welcome back our featured speaker, Mr. Mark Richardson. He is a former assistant prosecuting attorney for water quality in Macomb County, Michigan. He's also an adjunct professor on environmental law at Oakland University in Southeast Michigan. Today's 1-hour lecture will focus on the Federal Clean Air Act and climate change. For all our listeners, please post your questions in the chat box, and I will lead a Q&A session during the last 15 minutes. And just to avoid interruptions, please remember to mute yourself. For starters, subsequent to last week's lecture on toxic and hazardous substances, we had a question from one of our ECT team members. Mark mentioned that not all waters in Michigan are protected for the full body contact designated use, but they are protected for partial body contact. You'll notice in the chat box, we posted a link where you can learn more information about which waters are protected for that full body contact. And I guess with that, I will turn it over to you, Mark. And again, put your questions in the chat and we'll try and keep facilitating these to Mark as we go.
Thank you very much, Andy. Happy to be with you this afternoon to discuss one of the most significant federal environmental laws that we have, the Federal Clean Air Act. A lot of material to cover as usual, so it's time to dive right in. The modern Clean Air Act, next slide, thank you, was passed initially in 1970, amended significantly in 1977, and again in 1990. It combines several basic approaches to environmental protection that we see throughout U.S. environmental law, and I'm going to be focusing on 3 of them. The ambient standards approach, the technology-based approach, and the emissions trading approach. And we'll try and discover how these approaches interface with one another and work to protect us against unhealthy concentrations of pollution in the air. So the Act regulates both stationary sources of air pollution and mobile sources of air pollution in different ways. And I'm going to focus for quite a while on the stationary sources. I'll mention mobile sources a little bit later. The linchpin of the Clean Air Act is the National Ambient Air Quality Standards. And these were first promulgated in 1970, took effect in 1973, and have been changed and amended since then as scientific knowledge of the harmful effects of air pollution continues to be developed. It's important to realize that these standards are based strictly on regulating air contaminants to levels necessary to protect human health and the environment. There are 2 different types of NAQS standards. Primary standards protect human health, including the health of the most vulnerable parts of the population, such as people with lung diseases, elderly people, children, and secondary standards, which protect against environmental degradation generally. By far, the vast bulk of work in this area under the Clean Air Act has been on the primary standards. What is the nature of these standards? You have a series of slides telling us what they are. They are concentration limits expressed over time, and they're typically short-term and long-term concentrations to account for both acute effects and chronic impacts of air pollutants. To what set of air pollutants do these standards apply? Now, that's a great question. There's a list of 6 common air pollutants to which national ambient air quality standards apply. Sulfur dioxide, particulate matter, both fine and larger particulates, carbon monoxide, nitrogen oxide, ground level ozone, and lead. These pollutants are characterized by being very ubiquitous, particularly in urban environments, harmful to human health, and stemming from a multitude of sources, both stationary and mobile. How does the Act work to protect us against the harmful effects of these criteria pollutants by achieving the national ambient air quality standards? How does that actually work? It works primarily through a mechanism called the State Implementation Plan, or as nerds like me call it, SIPs. It's found in Section 110 of the Clean Air Act. And state implementation plans, as the name implies, are primarily the responsibility of state and local governments. The way the Act is set up, the federal government promulgates basic standards, basic rules, a basic framework for achieving air quality, and state and local governments are charged with implementing those that framework and those standards. I should note that the federal standards are a floor, not a ceiling. States are free to enact more stringent standards than the federal, and they're also free to enact standards for pollutants not covered by the federal legislation. So what's the state implementation plan? Well, I'm not going to go over every single feature, but basically it's an action plan that you ought to be able to pick up and, in plain English, read a plan which convinces you that air quality is going to be improved to the point where it meets the national ambient air quality standards, or it's going to be maintained at levels which comply with those standards. A SIP has to include authority to regulate the main sources of these criteria pollutants, these 6 pollutants. And those are major stationary sources, defined as a source that can emit, capable of emitting 100 tons per year of any air pollutant. And then there's a couple of subcategories, 25 tons per year of any combination of hazardous air pollutants. I'll talk about hazardous air pollutants in a few minutes, or 10 tons per year of any single hazardous air pollutant. The SIP has to contain a timetable for attainment of the air quality, national ambient air quality standards for these pollutants by regulating such sources. In that timetable is basic timetable in the Clean Air Act is a 3-year timetable. There's been some tweaks to that, as I'll go into. A SIP has to include specific limitations and controls on sources, on major stationary sources. How much are they allowed to emit? Monitoring requirements, provision for pre-construction review of new sources. We don't want to clean up the air and then have it dirtied all over again by adding new sources. One last thing about SIPs. It may sound counterintuitive, but a SIP cannot be modified on the basis that it's not feasible to achieve the goals of the SIP within the 3-year time limit. You may be asking yourself, well, how can that be? If it's not feasible, what are we talking about? Yet there are court cases that say exactly that. You can't back off the plan because the state has no money, or you know, the sources have no money, or what have you. Your plan has to provide for achieving these standards within 3 years. What does this add up to, this approach? It's a technology forcing approach. In other words, set the goal beyond what's currently possible and challenge the regulated community to meet that goal. And as we'll see in a little while, that's not an unrealistic approach. Now, when we talk about air quality we are talking in regard to the criteria pollutants. We're really talking about two kind of halves of a whole, or two universes. We're talking about areas that attain air quality standards for criteria pollutants and areas that don't attain the air quality standards. And it's important to understand, just for clearly thinking about this, that the same area can attain some air quality standards for some pollutants, but not attain them for others. So that area, sources, a single source in that area has to comply, if that's the situation, has to comply with two different kinds of standards. So now I'm going to explain what standards apply and what additional requirements, that is, apply in non-attainment areas where the air is still too dirty. And this is where we get into another basic approach to environmental regulation. What I've been describing for you so far is a kind of a work backwards from the ambient situation approach. And it's a very complicated process to you know, put together air quality models and work backwards from pollution levels to the actual sources, figure out what the contribution of those sources are and how they should be regulated. That's the ambient approach. There's another approach called the technology-based approach. And in areas that don't attain standards, sources are also subject to special or specific technology-based regulatory requirements. Specifically, existing sources within those areas have to comply with a level of technology-based pollution control called reasonably available control technology, or RACT. New sources have to comply with a more stringent standard called lowest achievable emissions rate, or LEAR, plus offsets. They have to not only install stringent control technology on a new source, but the new source has to produce proof that what it's adding to the contaminated air is offset by a corresponding reduction from another source within that area. That's what an offset is. And that's a kind of a primitive form of emissions trading, which we'll talk about later as well. The shorthand way to think about the difference between RACT and LEAR is the requirements for existing sources are an average of the best current performers in the field, kind of an average of the best. LEAR, lowest achievable emission rate, is the best single performer. That's the gold standard that a new source has to meet. And just to borrow from what I said a couple of weeks ago in connection with the Clean Water Act, technology-based standard, every word in that description is important. A technology-based standard does not require a specific technology. A technology-based standard is a number, which in turn is based on demonstrated results from technologies. How the source gets to that number, which is in a legally enforceable number, is up to the source. In most cases, it probably will install the baghouse scrubber or the electrostatic precipitator that achieves that goal, but it doesn't have to, and it can do it some other ways. So there's some flexibility there. I've talked a little bit about non-attainment areas. What about areas that are in attainment, where the air is cleaner than the standards? that's covered by a section of the Clean Air Act called the Prevention of Significant Deterioration Program, or PSD program. And what the PSD program does is basically divides every part of the country where the air is cleaner than the standards into three categories. Class 1 is special category for national parks, wilderness areas, national monuments, areas where the air is the cleanest, and basically no incremental pollution is allowed in those areas. Class 3 is a rarely used category that basically consists of areas that are just incrementally below the standards and perhaps are reserved for industrial use. That's a rarely used category. Most areas of the country that comply with the NAAQS standards fall within Class 2. Now, how do we allow for economic growth in these areas, new smokestacks, without causing a violation of the NAAQS standards, dirtying up the air to unacceptable levels? We do so by actually requiring, we maintain a baseline information of the actual pollution levels, and then we allow periodic incremental addition of incremental pollution above those levels to a point below the standard, the NAAQS standard, and that's what we allow. And then the new sources that we allow to have that have to adopt a yet another technology-based requirement called Best Achievable Technology, or BAT. That requirement applies to major stationary sources, which is defined a little bit differently than the SIP part of the law does define it. In this section of the law, a major source is any source capable of emitting 250 tons per year of a regulated pollutant, or 100 tons per year of a regulated pollutant within any one of 28 specific categories. The batch requirement applies to new sources and, quote, major modifications, unquote, to existing sources. For years, there are bloody battles in this field over what constitutes a major modification. You can see that, for example, a utility company operating coal-fired power plants might wish to continue operating those plants instead of rendering them uneconomic by installing by installing BAD, excuse me. So they might be tempted to just make small modifications every year to stay under the radar of a major modification. So there's been a lot of bloody litigation over what is a major modification. But what is BAT? That's slightly different than the other technology-based standards that I've described so far, because it is not a uniform technology-based standard. It is a case-by-case technology-based standard. The permitting agency will decide on a case-by-case basis just what is best achievable technology. There's a lot of wiggle room within that process as well. If I had time, I could tell you some war stories about what BAT really might mean. It might surprise you. But I need to get back to the main road here, and there's a couple of more things I need to describe for you to fill out the basic framework of the Clean Air Act. One is new source performance standards. We're back now to uniform national standards. What the EPA has done is studied different kinds of industrial sources and has established control technological controls for about 80 categories of sources. And this set of requirements pertains strictly to new sources. It doesn't matter whether you're in an attainment area or a non-attainment area or where you are. You have to comply with this baseline technology if you're a new source in one of these 80 categories. And the technology-based requirement here is called Best Adequately Demonstrated Pollution Control Technology, or BDAT. So this is acronym heaven, you know, and it just gets worse. But BDAT is again an average of best. Most of these technologies that I'm describing kind of incorporate cost-benefit analysis by implication, because they wouldn't be out there in use if they weren't economical to use. So cost does play a part in evaluating and adopting these technology-based standards. And I'm just pointing it out to contrast that with the ambient standards approach of the National Ambient Air Quality Standards, which those are not based on cost-benefit analysis. Those are based on human health or protecting the environment. Why have this independent set of standards for these 80 categories? It's to prevent, you know, a race toward laxity, a phenomenon of locating new sources in areas where the air is clean, so that you don't have to comply with the stringent standards of LAIR, the best performer in the field. If you have a sufficiently stringent level of technological control for all new sources, you kind of neutralize this temptation to move around and dirty up the air where it's already clean. By the way, everything I'm telling you today has a real world war story tale attached to it. I wish I had time to actually do those. Move around to avoid dirty air and get clean air. Yes, indeed. I'm aware of that happening. Obviously, there are more air contaminants than just 6 of them. We all know that. There are thousands of chemical compounds that go into the air, and the EPA has actually identified about 200 chemical compounds and other substances, metals, that have been deemed especially hazardous to human health, especially on an acute exposure basis. And there's a section of the law that deals with hazardous air pollutants, or HAPs. This is an interesting contrast between the ambient standards approach and the technology-based approach. The original approach toward HAPs, hazardous air pollutants, was a ambient standards approach. Study, you know, it's going to be based on harm to health. Review all the medical studies, all the scientific studies, try to determine what an acceptable level of exposure is, work backwards from that to exposures in different industrial scenarios, and try to establish standards for all of the different sources of hazardous air pollutants. Progress under that approach proceeded at a glacial pace. It's just too complex to make rapid progress. We don't always have adequate data about what the health effects actually are of these substances. Well, we know most of them are bad. So in 1990, the Clean Air Act was amended. The ambient approach, the health-based, risk-based approach, was scrapped in favor of a what? Of a technology-based approach, of an approach that focuses on minimizing emissions rather than the impacts of those emissions. Just get the emissions down as low as you can is the approach. And under this approach, a lot of progress has been made. We now regulate almost 200 hazardous substances since the 1990 amendments. And again, we're talking here about uniform technology-based standards. And there's yet another acronym to deal with here, the Maximum Achievable Control Technology, or MACT, is the technology-based standard used to regulate HAPs. And that MACT is equal to the top 12% of performers in categorized sources. An interesting feature about regulating HAPs is it's done through a permitting program, 5-year permitting program. This is the first time that the federal level has actually directly permitted sources. Heretofore, it's relied on the states to do that. But the reason for a 5-year permit is it has to be, as it's renewed and more is known about the characteristics of these hazardous substances, the more stringent MACT requirements can be installed. And as technology improves, that's another factor for limiting the operating period to 5 years. Okay, so we're almost a half hour into this thing. What's been the result of all of this activity? We have made terrific progress, really, to control the criteria pollutants. I'd like to direct your attention to the slide that covers, maybe go back a couple slides to the trend lines for economic growth, and yeah, the one before this, I think it is. The slide just before this. There we are. All these requirements, except the HAP requirements, really only began to effectuate around 1980. It took years for the requirements to phase in, and et cetera, and for their impacts to be felt in terms of air quality. This is a very interesting graph, evident even as somebody who's colorblind like I am, showing that since 1980, the gross domestic product of the United States has, well, it's not quite doubled, but it's getting to that point. There's going to be a little bit of a dip as we carry that into 2021, but 182% growth. Also significant growth in vehicle miles traveled. We have more cars and we're driving them farther. Population has grown by approaching 50%. But the interesting parts of this graph are below the median there. It shows that the energy consumption, total energy consumption, has only increased by 28% during that period of time. And we have all this growth. And the money line is the bottom line. This is an aggregate of emission levels for the criteria pollutants I've been talking about, aggregate of the criteria pollutants. A decrease of 71%, over 2/3 decrease. At the same time, we have a lot more miles driven, a lot of growth in gross domestic product. With this is showing us a dramatic drop in criteria pollutants at the same time that we're economy is managing to prosper. Some would argue that there is a direct connection between minimizing health risks and economic growth. If we could go to the next slide. This shows us that there is still more work to be done. And if you look at the top two bars, this shows us that there's still about 82 million people in the country that live in areas where there's one or more NAQS standard is not complied with for a criteria pollutant. This relates just to the ozone criteria pollutant. 74 million people live in areas that don't comport with the ozone requirement. So the lion's share of this top bar really consists of ozone exceedances. There's also some non-compliance in terms of particulate matter, but that underscores that ozone is really our major remaining urban air quality problem. And what the EPA, and it's persistent because primarily because of the growth of automobile travel, urban sprawl, all contribute to persistence of ground level ozone. And so in 1990, recognizing the lack of progress on ozone, the act was amended to provide for extended timetables to achieve the ozone NAQS, and divided the ozone non-attainment areas into 5 categories. Love these: marginal, moderate, serious, severe, and extreme. The only extreme area is actually Los Angeles, California. In addition to extending timetables, these areas are subject to, ratcheting up their plans to minimize ozone precursor emissions. That's where we get things like dedicated car lanes, carpools, increased mass transit planning, fuel blending, and electric. In California, a percentage of the fleet is going to be electric. Increasingly drastic measures depending on severity of the ozone problem. Okay, have to move on here at the dramatic clip. So I just want to mention the third major approach. I've kind of alluded to it when I talked about offsets, but the Clean Air Act also incorporates an approach that we would call an emissions trading approach. And this is premised on the notion that all that really matters is the aggregate level of pollution, reducing the aggregate level of pollution to a point where the air is healthy. Who is actually contributing to the pollution is a secondary concern, and that is actually a more complicated question than it sounds, because different pollutants have different environmental fates. Some, like mercury, for example, has local impacts. SO2, on the other hand, basically goes up into the stratosphere and goes long distances. So you have to allow for the fact that there's different environmental fates for these different pollutants when you're talking about whether you can apply an emissions trading approach. But the idea here is that if it doesn't matter who's contributing what, then you ought to let all the sources, you ought to give them maximum flexibility to comply with the law, as long as the aggregate results are satisfactory. So if you do that, then you can assume that high cost polluters will be willing to purchase pollution rights from low cost polluters, because low cost polluters, it'll be cheaper for them to install control technology and perhaps control their emissions to a point below that they might otherwise have to, and create an excess of pollution rights for themselves, which they can in turn trade or sell to a source that for which it's more expensive to retrofit their facility. And so you'll wind up with some sources emitting more than other sources, but as long as the aggregate is sufficient, is satisfactory, it'll be okay. And the program that successfully deployed this approach in the Clean Air Act is the Acid Gas Emissions Control Program. And that addressed the problem of acid rain, acid precipitation from large Midwestern coal-fired power plants impacting forests and lakes in the east with acid precipitation. And the EPA established, did an initial distribution of pollution rights allowances based on a ton of SO2 per BTU produced, and establish initial cap. And then it told everybody it's going to lower the cap, the overall amount of pollution from all these sources that will be allowed in 5 years. So the sources commenced to trading amongst themselves to arrange who can reduce pollution the cheapest. And that program has been extremely successful. And it's a good segue into talking about climate change, because cap and trade is one of the primary methods in use today in the world for addressing climate change issues. Now, what about the Clean Air Act and climate change? First of all, I need to say flat out that the U.S. Approach to controlling greenhouse gas emissions is on the verge of non-existent. However, the law does require that the government control greenhouse gas emissions, and the law the vehicle for doing that is the Federal Clean Air Act. In the case of Massachusetts versus EPA, the U.S. Supreme Court in 2007 ruled that greenhouse gas emissions were an air pollutant within the meaning of the law, which had to be regulated upon a finding of substantial endangerment by the agency. The agency did do that in 2009. That finding of substantial endangerment has never been challenged by the Trump administration. It's still in place, so the obligation to regulate greenhouse gas emissions under the Clean Air Act remains in place, and there has been some response to that by the Trump administration. But I want to contrast. I don't have a whole lot of time to paint the picture of the challenge that we're up against. It is a worldwide problem. The United States, however, is a huge contributor to that problem and must exercise leadership in order for the world to get control of that problem. You can decide for yourself what kind of job we're doing after I'm finished with my remarks. The Obama administration was a signatory to the Paris Accord and made pledges, non-binding pledges, just like all the other pledges in the Paris Accord are non-binding, but they're good, non-binding, good faith pledges to reduce greenhouse gas emissions, aggregate greenhouse gas emissions by 32% by 2030. The interesting thing about the Paris Accords that nobody likes to talk about is that, except people like me, is that at the time it was signed in 2015, we were already halfway there. We were already halfway toward the goal of reducing emissions 32% by 2030, because we'd already reduced emissions about 15% from 2005 levels. The 32% is measured from the year 2005. We've already done that. Anyway, what was the Obama administration's response to its pledge? It did two things. I haven't talked much about regulating motor vehicles under the Clean Air Act. That is a direct federal responsibility. That's oversimplifying it, because states have limited options to impose further regulations, which are currently under challenge right now by the Trump administration. But the Obama approach is twofold. One was to increase auto emission standards, and under the Obama rule, the fleet averages for domestic automakers were to increase 5% a year up to the year. Fleet average emission reductions would increase 5% a year to the year 2026, resulting in a projected reduction of 21% greenhouse gas emissions from the country. The Trump administration has scrapped that rule and substituted a rule which calls for increase in auto mileage emissions I'm using the word emissions wrongly, increases in auto mileage, 1.5% per year up to 2026, a significant reduction in what the Obama administration rule had been. But what about stationary sources? The Obama administration chose to tackle the power sector. That is a significant element of the greenhouse gas emission picture in the United States. It did so through a rule called the Clean Power Plan. And I'm running out of time here. For nerds like me, the Clean Power Plan is like a fascinating approach, but let me see if I can describe it very quickly. The idea was to get greenhouse gas emissions, to cut them on a per BTU basis, okay? Per unit of power basis. And the Obama approach was to identify four ways that you could approach the task of cutting on a per BTU basis. And the interesting thing about these four building blocks is that they don't necessarily pertain to just what's going on in the power plant itself. The four building blocks, by the way, are greater efficiency in energy production, which would be improved in-house efficiency, greater use of low emitting facilities, natural gas combined cycle facilities, substituting for coal, greater use of zero and low emitting facilities, renewable energy and nuclear, and greater efficiency in energy use, increased demand side efficiency. And that, of course, is something that goes on in the community, not at the power plant. It determined that using a combination of these four techniques could realistically be expected to cause the United States to achieve its goal of a 32% reduction by 2030, in combination with the motor vehicle rule. How was this going to be implemented? It was going to be implemented by giving states maximum flexibility to apply one or more of these four different approaches to that state's goal for emissions reductions. Each state was given a goal for reducing emissions based on the existing power mix, baseline power mix within that state. Heavy states more reliant on on fossil fuel use had greater emission reductions targets. Some states had zero reduction target because, believe it or not, some states don't rely on fossil fuel at all, like Hawaii, for example. But as long as it met the target, the states were to design their own plan, utilizing any combination of these approaches, these four approaches, that would achieve the target. This rule was rescinded by the Trump administration, and because it's still under legal obligation to do something under the Clean Air Act, the Trump administration substituted a new rule, and that's called the Affordable Clean Energy Rule. The Trump rule focuses on, pardon me for calling it by the president's name, I'm sorry. It focuses on strictly on what goes on inside the power plants, efficiency improvements in existing power plants. The new rule does not contain any targets or any minimum efficiency standards for the improvements that are contemplated. It leaves everything entirely up to each individual state to establish those rules. It's very uncertain how effective this new rule will be. And I'm mentioning both rules because everything I've talked about along in climate change is in litigation right now. We do not know what the outcome will be, what the ultimate policy will be. But by giving you what's happening, and I'm describing, what's on the table, and what the outcome will be is highly uncertain. So I am at 1:45. I think I can probably stop here. There were some questions. There was a series of quiz questions at the end of the slides. And we can.
So for today's talk, everybody, we thought it would be interesting to pop a couple questions in a quiz format and try and make it a little engaging and test our knowledge. So we'll run through, there's 4 quiz questions. And then I think if anyone does have questions, please put them in the chat. It doesn't look like there are any at the moment. So we can just start with this first one. Question 1, what does NSR stand for? We have non-subsidies review, new subsidies review, new source review, and national source review. Next slide will reveal our answer when you're ready. It is new source review, NSR.
Bingo. Well, I don't know what I say. I guess I say, yeah, okay.
And number 2, what does PSD stand for? So we have protective services detail, pollution service data, prevention of significant deterioration, or pollution spectral density.
Ooh.
It is prevention of significant deterioration.
We have a star out there. We have a budding star out there. Only 2 more and it'll be 100% is in sight.
All right, question 3. Coal-fired plants emit nitrogen and hydrogen, oxygen, sulfur dioxide and nitrogen oxide, or all the above? It is sulfur dioxide and nitrogen oxide.
I can agree with that.
Looks like Amrita got it right.
Yeah, she's holding out on us. I think there's probably something in her background.
What does HAP stand for? Hazardous acute pollutants, high air pollutants, hazardous air pollutants, or heavy air pollutants?
Yes, it is 3. Actually, those others you could use them. You could use those to actually describe a HAP, but the real definition is hazardous air pollutants. Yes.
Great. It looks like a few others got that one right. Annette, way to go. Okay, any other questions
So
people may have today? If not, unless you have more to add, Mark, we have a few minutes, but I think we can, I thank you again. I know this has been really informative for all of us, especially folks not in this particular line. So we appreciate the time you've taken to educate us. And I will remind you, next week is the last of the 5-part lecture series. And the theme of that talk is protecting wildlife and preserving biodiversity under the Endangered Species Act.
I guess I would just say, does everybody understand why I said that the cap and trade, which was pioneered within the acid gas emission control section of the Clean Air Act, why that's particularly appropriate for control of greenhouse gas emissions? The 4 building blocks I talked about, they didn't explicitly include cap and trade, but you could use cap and trade to get at particularly the in-house improvement building block of that of that approach. Also, Europe has a cap and trade scheme. The European Union has a cap and trade scheme. And there are local cap and trade schemes operating currently on the North American continent. There's one operated in the Northeast states, and another one actually involving the state of California and the province of Quebec in Canada. This what experience has shown with these programs is that the costs of acquiring pollution rights, their emission allowances is what they're called, has consistently proven to be lower than anticipated, because the cost of retrofit, the cost of technology has consistently proven more affordable than has been predicted. So it almost seems like we just need a nudge in the right direction, and scientists and engineers get to work and find cost-effective solutions to these problems.
Well, thank you for pointing that out. That's a great point. For everyone on the call, there were some slides that included a lot of data that might be interesting for you to go back and check out after the fact. So again, this will be posted on the source. And if you have any questions, feel free to shoot them over to me, acooper@ect.com. And we look forward to seeing everybody next Friday for our last gathering.
Okay, thank you.
Thank you, Mark.